Hello everyone, and welcome to Lesson 5, Part 1 on some useful functions that I use fairly frequently when I'm working with data in R. And so I just wanted to expose you to these functions so that you can see them and start using them and get the hang of them early on, because you'll be using them fairly often. All right, so I'll jump right in. So first we have a set of basic summary functions, or functions that you can apply to a vector of values to extract the mean value, the maximum value, minimum, the length of the vector, the unique values in the vector, a table of how many times each unique value occurs, and an overall summary. So here are just some vectors we have to work with. So first let's run that. So we have vector 1 in our environment, and then we can simply apply the mean function just like this. Of course, as we worked with functions so far, it's simply writing out the function and then putting in the arguments inside parentheses. And here we can see that the mean value of vector 1 is 25.76471. It's as simple as that. We can do the same thing with the maximum value, the minimum value, the length or the number of elements, all the different unique values. Oops, vector 1. And then we can see how many times each unique value occurs in vector 1 by using the table function. This is probably the most underrated useful function I've ever used in R. I use it all the time. It's just a great way to get a nice little summary of especially categorical data as you're working with your data sets in R. So here you can see that the first row of values here are each of the unique values in your vector, and below that we have it's essentially a name similar to a named vector, where we have the names as the unique values, and underneath it we have a vector of the number of times each unique value occurs in your data. And then there's the overall summary function, which gives you a few of these values all at the same time. The minimum value, the first 25% quantile or the first quartile, the median value, the mean, the third quartile, and the maximum value. And note that a lot of these functions can also apply to non-numeric vectors. So here we have a vector of DNA nucleotides, and of course if we tried to apply the mean to this, we'd get an error, but we could apply the table function. Oh wait, we have to run this first. Or maybe I did already. Oh, I did already. Okay, anyway. So vector to apply the table function, we can see that there are 3 A's, 2 C's, 1 G, and 1 T in this vector. And note that you may also have missing values in your vectors. So let's define a new vector, just kind of picking random values here, but then let's put in an NA. So in this vector, we have a missing value represented by the NA. So if we were to try the mean function on this vector, the output would actually also be NA. And that's because since NA represents a missing value, it's actually impossible to calculate the true mean of this vector since we don't know what this value is. And for that reason, the mean comes out as NA. But oftentimes you'll still want to know what the mean value is, or the maximum or the minimum, regardless of these missing values. And in that case, you just add the argument na.rm, which is short for remove. So na.remove equals true. And that will simply remove the NAs and calculate the mean while excluding them, just like that. All right, so sometimes we need to pick random values from a vector because we need a random subset of our data for cross-validation, or because we just want to play around with something and don't need the full data set, or maybe we just need a random number for a simulation we're running. The simplest way to do this is using the sample function, which takes several arguments. And if you've noticed up until now, whenever we type in a parenthesis, we get this pop-up which actually helps us see what possible arguments we can add to a function. In this case, for the sample function, first argument, or x, represents the vector that we want to sample from. The next argument, size, is simply how many elements to sample randomly from that vector. And then the default replace equals false means that the values will not be replaced, so it's sampling without replacement, but you can also make that true if you prefer to sample with replacement. And then prob is an argument where you can supply a vector of probabilities with which to sample from x. And the default of prob equals null is simply giving equal probability to all the elements in x. Okay, so let's put in the first argument would be the vector. So let's put in vect1 and then size equals 5. We'll sample 5 elements randomly from vector 1. So there you have it. And of course, if you run this again, we'll get 5 other elements because this is always random. Then the functions rnorm and runif sample values from a hypothetical normal distribution or uniform distribution. So in this case, the arguments are n, which represents the number of values to sample. And then because this is a normal distribution, we can set the mean and the standard deviation, and the default mean is 0 and the default standard deviation is 1. So if we just do n equals 5, we'll get 5 random values from a normal distribution with a mean of 0 and standard deviation of 1. Similarly, for the uniform distribution, the first value is the number of samples to take. The second is the minimum value from that uniform distribution. The second, and then we have the next argument is the maximum value. So we could do n equals 5, min equals 5, max equals 6. So now we'll get 5 random values between 5 and 6, and that's what we get. All right, now on to some sorting functions. So sometimes you'll want to sort a vector or find the order of elements in that vector. And it's as simple as applying the sort function. In this case, the default is to sort in ascending order. So these are all the elements in vector 1 sorted in ascending order. And if we want a decreasing order, we could just type in decreasing equals true. That's just an additional argument we can add, and now it is that vector in decreasing order. As simple as that. Now remember that up until now, every time we apply a function to a vector or any kind of variable, the original value of that vector or variable doesn't change unless we were to reassign it. So if you rerun vect1, we still get these values. So we'd have to reassign to itself in order for these values to change and update within that same vector, but we don't want to do that yet. So I'm just going to comment this out by putting that pound or hashtag there so we don't actually run that. And you'll find that many times when you're working through the code, you'll want to look at various aspects of the data throughout the code, but then you don't want those to run later when you're running the entire code, so you can comment lines of code out just like that. And you can actually use the keyboard shortcut Shift Command C or Shift Control C for PCs. And wherever your cursor is in the code, those lines or whatever lines of code you select, if they're already commented, then they will uncomment, and if they are not already commented, then they will comment out when you do the Shift Command C. So I do that fairly often, just a neat trick. Okay, so we can also extract the order of the elements in vector 1 based on decreasing or increasing order. And we can just do that with the order function. When we run this, essentially we get a vector of the indices in vector 1 in ascending order. So for example, this first element after applying the order function, 16, tells us that the first value of an ordered vector 1 would be the value at element 16, which in this case is the 1. So the 1 would be in the first place. The next value would be the 8. So if we count 1, 2, 3, 4, 5, 6, 7, 8, that would be this 2. And because you have these other 2's right there, it's 8, 9, and 10. And then 1 tells us that the first element, so in this case the 4, would be the next, and so on. So I won't go into more detail than that. It's just a quick way to get the order of a vector, and it may come in handy later as you're exploring and reorganizing vectors. So I just wanted to show you that. It's not, I don't use it as often, but it's just good to know and keep in mind. All right, so with that, that's it for part 1 of basic functions. To quickly summarize, we went over summarizing vectors using some of these basic summary functions, went over how to pick random values from vectors or from a normal or uniform distribution, and finally how to sort vectors or extract the order of values from a vector. Next, I'll go over how you can actually create your own functions. So up until now, these functions are fairly black box, and you put in the arguments and out pops an answer or result or value, but sometimes you might need more complex functions or unique functions for dealing with your data. And so next we'll talk about how you can actually create your own functions, and also we'll talk about how to find help when you need it as you're coding in R. So with that, thank you so much for listening, and see you in the next lesson.